Is Algebra 1, Lesson 9.2. We are simplifying radicals. We're using their properties to simplify them. We're going to look at them in a real-life example beginning on page 511. We have a definition. What is simplest form? The simplest form of a radical expression is an expression that has no perfect square factors other than 1 in the radicand, no fractions in the radicand, and no radicals in the denominator. So all of this, what this is saying is you have to ask yourself 3 questions to determine if something is simplified or not. If you answer no for all 3 of these, then it's considered simplified and it's finished. The first question, everybody write this down if you don't have this. The first question, and you probably don't, the first question is perfect factors. We're going to write it as short as we can. Perfect factors, question mark. Number 2, fraction under the radical. Number 3, radical at the bottom. Those are the 3 questions. We need no for all 3 of those. We need no, no, and no. If any of them are yes, and I'll show you what these symbols mean for the second 2 when we look at the division ones. If any of them are yes, you have got to separate it and you've got to reduce it further. You have to simplify it even further. So perfect factors, fraction under the radical, radical at the bottom. That's all that says up there in red. Here are your properties of radicals. One of them involves multiplication. The other one involves division. So what it says is the square root of a product equals the product of the square roots of the factors. So what this is saying is the number 10 is the same thing as 5 times 2. It's saying that you could separate any number you want into 2 of its products. That's why it's the product property. The example that goes along with it is the square root of a times b. That can be separated into the square root of a times the square root of b. And then it's just simply saying when it says a and b have to be greater than 0, that you can't have a negative value, because the square root of a negative number is going to give you something that, remember, you can't have the square root of a negative value. The quotient property says the square root of a quotient equals the quotient of the square roots of the numerator and the denominator. That's even easier than it sounds too. What it's saying is the square root of, notice there's a fraction underneath the radical, a over b, can be separated into the square root of a over the square root of b. Again, where your values can't be negative. That's what a is greater than 0 and b is greater than 0 means. So let's look at what that means when you start putting values and variables with it. Simplify the expression, the square root of 27. Now we know what our perfect squares are. Our perfect squares are when we multiply our integer numbers times themselves. 1 times 1 would give us 1. We don't need to use that as a factor because it doesn't reduce anything. It doesn't simplify anything. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. We'll focus on those perfect squares up to the number 12 times 12. There will be a time where you're going to use 13 and 14 and 15 and 25 and all of that. But these are the ones we'll focus on. These are the ones we'll use primarily. What you want to ask yourself, remember, any number can be separated into 2 factors that multiply by it. So what are your factors? And we've already done factoring trinomials in here where we made it 2 binomials. What are your factors of the number 27? We know 1 times 27 gives us 27. 2 doesn't go into it. 3 does. What does 3 multiply by? 9. So 3 times 9. 4 doesn't go into it because 4 times 7 is 28. That's right next to 27, so it can't be something else. 4 times 8 is 32. 5 doesn't go into it because it doesn't end in 0 or 5. 6 doesn't go into it because 6 times 5 is 30. That's right by it as well. 7 doesn't go into it. 8 doesn't go into it. And we back to 9. So there's only 2 pairs. What you have to focus on, though, is these numbers that I have written in red right here, these perfect factors. Which one of those perfect factors is a factor of 27? 9 is, absolutely. 9 is the perfect factor. So what that means is the square root of 27 can be broken down into 2 separate square roots multiplying by each other. The first one is the perfect one, 9. 9 multiplies by what? 3. So what we have now is the square root of 9 times the square root of 3. We can take the square root of 9 because it's perfect. What is the square root of 9? 3. So we have 3 times the square root of 3. This is how you simplify a radical. So the square root of 9 is the square root of 9 of 27 is the square root of 9 times 3. That's what I just showed you. And the square root of 9 is 3 times the square root of 3. This is all you do to simplify radicals. You find a perfect factor, you put it first because the coefficient is going to be first anyways. So you put the perfect one first and you put the other one second, and then you do the perfect factor. That being said, in the margin right next to it, because you don't need a lot of space, or on the back because you got a whole back, simplify this one. What is the perfect factor? That's what you need to ask yourself of 48. Here are your perfect factors. 2 times 2, 3 times 3, 4 times 4, and so on and so forth. You don't have to check through a bunch of numbers. 4 absolutely goes into this. 4 times 12 gives you 48. But if we look past 4, 9 doesn't go into it. 16 does. 16 times 3 works. Let's pretend 16 is the best number. 25 doesn't multiply by anything. 36 doesn't. And 49 is already bigger than it, so that you don't have to work with that one. Let's pretend for a second that we don't know that 16 is the best number to go into it. Let's say that we use the number 4 because that's absolutely a perfect factor and it absolutely goes into 48. What do you multiply 4 by to get 48? 12. So now, what we want to do now is simplify it. The square root of 4 is 2 times the square root of 12. Remember those 3 questions I told you to ask yourself at the beginning to determine if it's simplified or not? Are there any perfect factors? Is there a fraction under the radical? Is there a radical at the bottom? Right now, there is a perfect factor inside of 12. What is it? Which one of these numbers multiplies by something to give you 12? 6 and 2 are factors of 12, but neither one of them is a perfect factor. These are your perfect factors down here. Which one of those numbers multiplies by something to give you 12? 4 does. 4 has to multiply by what? 3. What you can't forget, though, is you can't forget to bring this 2 down right here. So what we have now is 2 times, what's the square root of 2? Of 4. 2 times the square root of 3. And when we multiply 2 times 2, what do we get? 4. So when you multiply 2 times 2, you get 4. And 4 is multiplying by the square root of 3. Remember, ask yourself those 3 questions again. Any perfect factors? Any radicals underneath it? Or any fractions under the radical? No for all 3 of those answers. This is considered simplified. Fast. So for example number 2, we have the square root of 5 over 16 and the square root of 48 over 75. The square root of 5 over 16, the first thing you do with the quotient property is you separate it into the square root of 5 over the square root of 16. That's all you do. Then you take the square root of both of those if they're perfect squares. The square root of 5, there's no perfect square in it, but the square root of 16 is 4. That's all you do with that, the square root of 5 over 4. You do the same thing for b, the square root of 48 over 75. You separate them first. Okay, if you separated them, it will look like this, the square root of 48 over the square root of 75. And the perfect factors of each of those are 16 times 3 and 25 times 3. So right here, 3 over 3 will reduce. And that's how we get the square root of 16 over the square root of 25. The square root of 16 is going to be 4, and the square root of 25 is going to be 5. So 4 over 5 for that one.